Good day everybody. We've been given this question, e raised to the power of x positive e raised to the power of negative x is equal to 0. We are expected to solve this. That would mean we need to find all values of x for which this system is satisfied. Now just a side note, if you were being given e raised to the power of x is equal to 0, then clearly this has no solution. And also, if you were to be given e raised to the power of negative x is equal to 0, this too has no solution. But apparently, when these two equations are clubbed together and formed a single system of this fashion, they are having a solution. But it is not a real solution. Of course, it is going to be a complex solution in nature. And having mentioned that, let us embark on solving the system. So foremost, what I wish to do is I would like to consider e raised to the power of x positive e raised to the power of negative x is equal to 0. Now from the hyperbolic definition of cos, we know the following formula. So let me write that down. We know that cos x is equal to e raised to the power of x positive e raised to the power of negative x divided by 2. And this can be subsequently rewritten as 2 times cos x is equal to e raised to the power of x positive e raised to the power of negative x. So there is a equivalence relationship for e raised to the power of x positive e raised to the power of negative x in terms of the hyperbolic cos. So I would like to take this and substitute it here. So this would mean I got 2 times of cos x is equal to 0. Now let this be on one side. Let me consider the usual trigonometric ratio cosine. Let us consider cos x. Now cos x has a relationship which is written using the Euler's formula, which is e raised to the power of ix positive e raised to the power of negative ix divided by 2. Now you might be wondering, how on earth is this possible for us to write in this fashion? Now let me give it to you. So this is not part of the exact problem, but just as a side note information, additional information just for you all to understand how exactly we are getting this to be equal to this, right? Now Euler said e raised to the power of I theta is represented as cos theta positive I sin theta. Now subsequently, this would mean e raised to the power of negative I theta would be represented as cos. In place of theta, you got to substitute negative theta. In place of theta, you substitute negative theta because of the fact that you got negative sign there. Now this is equal to, since cos is an even function, I can write cos of negative theta to be as cos theta. But sine is an odd function, so this would mean I would have to rewrite this as negative I times sine theta. So this is what I've got. Now if I were to add these two things together, e raised to the power of I theta positive e raised to the power of negative I theta, then I would have the following. So this is equal to, write this down, cos theta positive I times sine theta, write this down, cos theta negative I times sine theta. Now clearly positive I sin theta negative I sin theta gets cancelled, giving me 2 times cos theta, but I need only cos theta, so bring this 2 down. So therefore we now have a representation for cos theta, which is nothing but e raised to the power of I theta positive e raised to the power of negative I theta divided by 2. So that is exactly what I have written there. Now let me go back. So let me mention this as 2. Therefore 2 can be rewritten as 2 times of cos x is equal to e raised to the power of ix positive e raised to the power of negative ix, right? Now if you were to look into cos x is nothing but e raised to the power of x positive e raised to the power of negative x divided by 2. Now if I would want to have a ix, then what should I do? I would have to substitute in place of x, I would have to place in I times x. So if I were to use in place of x, ix, then the system would actually change. How will the system change? Let me just place the information and show it to you. So this is going to be cos of ix. In place of x, I am substituting I times x. In place of x, this is going to be e raised to the power of ix positive e raised to the power of negative of ix. You got a 2 there, so place the 2 there. So what is this exactly? What is this exactly? This is nothing but the term that we have got, e raised to the power of ix positive e raised to the power of negative ix. Of course there is a 2 there, so I can substitute, in place of this I can substitute this representation, 2 times cos x. 2 times cos x. So what happens, this is, I'm using this space here, cos of I times x is now equal to, if I were to place 2 times cos x, 2 and 2 will get cancelled, I will just get cos x, that's it. So I hope you just saw that. Okay, let me just rewrite that because of the frame not being in viewable fashion. So let me write that down. So what I have got here is, I've got cos of ix is equal to e raised to the power of ix positive e raised to the power of negative ix divided by 2. Now in place of e raised to the power of ix positive e raised to the power of negative ix, I would like to substitute 2 times cos x. So this is 2 times cos x here. There is a 2 there, 2 gets cancelled, giving me cos x. So therefore I got a new representation. What is that? I got cos of ix is equal to cos x. This is really beautiful, right? Now moving on. Now just consider the original situation. From here I have got 2 times cos x is equal to 0, but I have a representation that cos of ix is equal to cos x. So let me write the situation here. From this one I can rewrite, or I can simply say from 1 we got, so what do we got? We got 2 times cos x is equal to 0. Now I would want to have a ix here. In other words, I would like to change, I think this is the best way to say, instead of saying I would like to have ix here, it would be better to state it in this fashion. I would like to change I times x to x. How is that possible? That is possible if you were to take x to be equal to negative I times x. So let me reiterate it. This is the system that we are left with. Over here we started the question and made use of the hyperbolic cosine function, and we arrived at the situation to be as follows. Now what I want to do is, if I want to solve the system with this given tool that we have just arrived, then I would have to suitably reform the tool, right? And that is possible in this fashion. I have got cos of ix is equal to cos x. So what I wish to do is, I would like to change x to ix. Now if I were to do that, let me take this as some 4. I'm not sure if I've used 3 anywhere, just in case. If not, let this be as 4. So in 4 we will take x to be equal to negative I times x. So therefore 4 can be rewritten as cos of I times of negative I times x is equal to cos, in place of x it is going to be negative I times x, right? This is what we've got. Now clearly, what is this? I into I squared, we got a negative 1, I squared is minus 1, so there is already a negative sign, so this is going to give me cos x. So cos x is now equal to cos of negative ix. So this is exactly what I need. Now go back to the question. From 1 we have already got 2 times cos x is equal to 0. Now if I were to take this as say 3, I see that I am not used to 3. So I'm taking this as 3. So therefore 3 can be rewritten as, in place of 2 times cos x, I am going to substitute cos of negative ix. So this is going to be 2 times, okay, so cos of negative ix is equal to 0, which would mean cos of negative ix is equal to 0. Now the question comes, when would this is actually an even function, right? Cos is an even function, but however, when would this quantity, cos of this quantity, be equal to 0? For what values? Clearly, this is only possible if I times x, because since we have got a negative sign, I'm placing negative sign exclusively. Negative I times x is equal to n positive 1 over 2 times pi, right? Because if you were to distribute pi, you get n pi positive pi over 2. Clearly, cos 90 is 0, right? So that is the reason I have represented negative ix is equal to n positive 1 over 2 times pi. Now, is it necessary that I need to place a negative sign? Yes, it's necessary. In the previous problem I represented, or in other words, I've explained to you how these signs becomes very much important when we are dealing with complex numbers. So that is the reason I have taken negative I times x is equal to n positive 1 over 2 of pi. Now, I need to get rid of this negative I. So what I would do is I would multiply by negative I both sides. If you were to multiply by negative I, again there would be I that would be reoccurring at the right side. So let us do that. So multiplying by I both sides, we get. So what do we get? You get negative I squared times x is equal to n positive 1 over 2 times pi times I. I squared is minus 1. Negative of minus or negative of negative 1 will be positive. So it's going to be x is equal to n positive 1 over 2 times pi times I. Now you can rewrite this as follows. So if you were to multiply or take 2 as LCM, so this is going to be 2n plus 1 divided by 2 times pi times I, which can be rewritten as, I'm going to write it in this fashion, I times pi over 2 times 2n positive 1, which is the value of x such that n is the element of integers. For all integers, x is equal to I times pi over 2 times 2n positive 1, and this is the solution for e raised to the power of x. Positive e raised to the power of negative x is equal to 0. So clearly you can see this has got infinite number of solutions. Thank you everybody. Enjoy your day.